In this video, I'm going to show you how to obtain chi-square test results like this column in this table. So as you know, if you use crosstab function in the SPSS, you usually just get one chi-square value by using two variables, two categorical variables. But how to obtain this? It's kind of post hoc test, but not really. So to answer this question, first we need to know how to calculate chi-squared by hand. Well, you can open any statistic textbook and you see a big nice function formula like this. I just search chi-square test in YouTube, but if you open any statistic textbook, you'll see the same formula. So this thing here, it stands for chi-squared. It's actually a value. This sign, it means sum, means that add up all the values after it. The O represents observed value in that cell, and E represents expected value in that cell. So let me pull out my SPSS data set, and you'll see what I'm talking about. Okay, so let me just do a crosstab, and let me reset. So we want something similar to this table. So we want the three levels of smartphone addiction in the column, and we want one behavior measure of smartphone use as a row. So the smartphone addiction level, I believe it's this. Let me show the variable names. Okay, so let me do columns. Let's see. I don't exactly know whether it should go to row or column. Let's do the hours of smartphone use after 11 p.m. Okay, and if you just pick, typically we just take chi-square. But we also want to select in the cell. We also want to see know the expected value besides the observed value. Yeah. Okay. So just click continue and okay. Okay. So okay, that's not good because we don't want that. Okay, let me try a categorical variable. Yes, I picked a non-categorical variable. Let's see. I'm just trying to pick a non-categorical variable. Let me do just gender. Yeah, because there's like male and female, so it's easy. Alright, click continue. So these are the observed values, and these are the expected values. So for non-addict, there are 113 male and 103 females. For the possible addicts, there are 317 males and 279 females. So we got all these numbers. It's nice. And now we're gonna do, because we need to do some math, so Excel, and we need these numbers. So I'm just gonna copy and paste. By the way, how you do any copy and paste in SPSS output, you need to first double click the table that you want to get the numbers from. Okay, so copy that, and let me just open the random. Just open a random. Create a blank Excel. I'm gonna call it chi-square. Yeah, it doesn't really matter. It's for demonstration purpose. Okay, now I'm gonna paste those numbers in it. It doesn't have any labels, so you need to remember them. So those are, or you can type it out, it doesn't matter. So these are non-addicts, these are possible addicts, and these are addicts. And this is a male, this is female. Okay, so these are observed values and these are expected values. So what we're going to do next, we're going to actually do the math according to this formula. So we're going to first calculate the difference between your observed value and the expected value. And then second, we're going to square it. And third, we're going to divide it by the expected value. And fourth, we're going to add them up. Okay, so because this is what I need. I need a chi-squared value in this column. So let's do this. So for the first category, first value of this variable, because remember this is a gender variable that only has 2 levels of values. So for male, we're calculating 1 chi-square. Okay, so have that formula on the side in case you forgot what it is. Okay, so first is O minus E. Okay, that's the difference between the observed value and the expected value. Okay, so we're going to type equal. These are the observed values. So observed value minus the expected value, and hit enter. Okay, so that's B2 minus B3. So B2 is here and B3 is here. And hopefully I can just drag it over, and I can't do that. Okay, so this equals the expected value minus the observed value. And this equals the observed value minus the expected value, okay? And then, so this is O minus E. And then we need the square of that, okay? I'm typing out the formula, but you don't need to type out the formula, I'm just showing you. So it equals this number and times itself, okay? And now you can drag it over, because then Excel is smart enough to calculate that. Okay, so I just drag it over. Oh, I put my cursor on the lower right corner of that cell. This is how you do it. You move your cursor to here, to this cross, until it shows like the black cross, and then you drag it over. So this is the square of C8, and this is the square of D8. Okay, so nice. And next we're going to we're going to divide that number by the expected value. So that equals this number divided by the expected value, which is the cell. Okay. And let me see what I can drag it over. Sometimes it does. It's Excel. Okay. So this, let me just check. The C9 divided by C3. Yeah, Excel figured out. Okay, so what we're going to do next is we're going to calculate that chi-square for the male. Okay, so that equals step 4, add them together, right? So this number plus this number and plus this number. Hit enter. Boom, you got a chi-square number there. How do I know this number is significant or not? In Excel, there is a formula that you can do that. So let's see, chi-square. Okay, let me do this chi-square test. So actual range and expected range. Oh, it actually does it for you. Oh, that's nice. Let me just do like the actual range here, and comma, and expected range. Let's see. Okay, so that gives me the chi-square test. So it's actually not smaller than 0.05. Okay. Let me try this chi-square. Let me try the first one. Oh, okay. Now I ask you for the chi-square number and degrees of freedom. Okay, let me do this one. And degrees of freedom is 2, because we only have 3 options. Okay, so that's the p-value. That's actually the p-value. So this p-value is not Well, if you do it, if you do like 2 tests, because we're doing 2 levels, 2 tests, you actually need to compare that instead of 0.05. You actually need to compare it to the. You have to do a Bufferoni correction. So you're doing 2 tests, right? We're doing one for male. We're doing one for female. So you should divide the original alpha level by 2. So we're doing 2 tests. So you actually need to compare that p-value. Actually, you need to compare that p-value to this number. So let's do it for the female. Okay. So first, we need to calculate the chi-square. We need the chi-square number, and we need the degrees of freedom. How to get the chi-square number? This number gives you chi-square number. So actual range and observed expected. Okay, so that's chi-square number, and we want a p-value, which is the first option here. So that's the chi-square value, and degrees of freedom is 2. And hit enter. So again, that p-value is not significant, because it's a good thing, meaning that the level of smartphone addiction did not differ between male and female. So that's good. Yeah, this number is significantly larger than the alpha level that you're comparing to. So back to that table. So what number do we put in there? Well, you put in a chi-square number, which is the first one. Okay, so this number for male and this number for female. About the stars, I mean, if your p-value is smaller than your Bufferoni corrected alpha level, then you put a star there. Yeah, so you need to divide all this number by the number of analysis that you're doing. Yeah, like in this one, if you're doing like 4 analysis, then you need to divide those alpha value by 4. Okay. I hope this video is helpful, and let me know if you find better methods to do this. And thanks for watching.